everyone, grade 12s. Today we are looking at analytical geometry revision. So the questions we're going to do in today's lesson come from the November 2015 paper, and I'll give you question number references as we go through the lesson. Now, as we go through our revision sessions, and as you would have seen in previous lessons, I like to give you little exam and study tips at the top of the lesson. So our tip for today is to prioritize exam revision. Now, many students believe that they are very good at multitasking. So, for example, chatting online, watching TV, and all of that while they are studying. However, research suggests that for the vast majority of people, this is not the case. It's really, really difficult to focus on your studying while you're talking to your friends online or while you're watching TV. So you need to eliminate all distractions to really absorb the material that you are studying, and distractions such as TV, of course, unless you're watching Mindset, then you've got to have the TV on because it's a study aid, right? So eliminate TV in any other circumstance, and loud music with lyrics so that you can really focus your attention. Rapidly swapping attention between studying and watching TV, for example, makes it more difficult for your brain to prioritize what the important information is. All right. So really just prioritize time when you can study in a nice, quiet environment. Okay. Now, in terms of the CAPS breakdown for analytical geometry in your exams, analytical geometry is roughly between 40 and 43 marks in paper 2. This accounts for maximum of 29% of your maths paper 2. Okay, some of the key concepts that you learn in grade 12 when we discuss analytical geometry. You look at the equation of a circle with the center at the origin. You are reminded that if P is XY is a point in a circle that is centered at the origin, so at the point 0, 0, and it's got a radius of length r, then the equation of your circle is x squared plus y squared is r squared. Now remember, this can actually be written as x minus 0 squared plus y minus 0 squared is equal to r squared, and this takes you back to when you're looking at the equation of a circle that's not centered at the origin, where remember that the formula where your center is AB is given by x minus a squared plus y minus b squared is equal to r squared. We can extend that concept back and say, well, for a circle centered at the origin, our points A and B are 0, 0. Okay, so you'll come back to the same equation if you are using an equation with or a circle with center A and B and a radius r. Okay, another important thing that you learn is that a tangent is obviously a straight line, but it touches the circumference of the circle at only one point. An important geometric concept that we use in analytical geometry is that the radius of a circle is perpendicular to a tangent at the point of contact. And certainly in some of the questions we're going to do today, we are going to use that theorem from Euclidean geometry. Okay, so it's one that you need to remember when you're dealing with this section as well. Okay, so as I said, we're looking at questions from past papers, and we're revising some of the analytical geometry questions from the November 2015 paper. So this question comes from that paper. It's question 3. I'm going to give you some time to take down the diagram, list the important information that is given to you in the first paragraph, and take down your diagram. We'll go through the questions together. I'm going to break this question up into parts, so I'll give you another chance later on to take down any information that you don't already have. All right. Okay, so I'm going to give you guys 3 minutes to take this down. Right, guys, so in grade 12, you know that your teachers always encourage you to have a look at past papers, especially for maths. It's a subject where you cannot learn things off by heart. That will only get you so far. You need to really be practicing so that you can understand the concepts that you've learned at the beginning of the year and then also from grade 11 as well. Okay, so this question comes from a past paper. It's from the November 2015 paper. This is paper 2. Let's first read the question together and mark down the information. So we are told that in the diagram below, the line joining Q with coordinates -2 and -3. All right, so let's have a look in our diagram. Where is that? So that's Q there in the third quadrant. So the line joining Q and P with coordinates in the first quadrant, which are A and B, and they tell you that A and B are greater than 0. Obviously, if you look at the way this diagram is positioned on the Cartesian plane, it makes sense for A and B to be greater than 0 because your diagram does have the point P in the first quadrant. And they tell you that that line makes an angle of 45 degrees with the positive x-axis, and that's at point T, as you can see there. That's 45 degrees. And the length QP is given as 7 square root 2. So let's mark that down. QP, the length is 7 square root 2. N is the point 71. And that's the midpoint of PR, and M is the midpoint of QR. So what you've got here are the two midpoints are joined together in that triangle PRQ. First question, determine the gradient of PQ. Okay, already by listing all of that information from the given information onto your diagram, well, it's already listed on your diagram, you should start thinking and formulating a plan. If they give me the angle that a line makes in the positive direction of the x-axis, the chances are they're going to ask you a question about the gradient or the angle of inclination, okay? And the first question proves that because the first question says, determine the gradient of PQ. Now, what you should remember is that the gradient of a line and the angle of the line are related by the ratio tan of theta is equal to the gradient. And remember, the reason for that is when we work out gradients, it's change in y over change in x. And by definition, tan of theta is opposite over adjacent, or y over x. And therefore, you can use that fact to help you work out the gradient when you've got the angle, or the angle when you've got the gradient. In this case, the gradient of line PQ is going to be given by tan of the angle that that line makes with the positive x-axis. And we are told that that angle is 45 degrees. So therefore, to work out the gradient of PQ, it's going to be equal to tan of 45 degrees. You shouldn't need a calculator for that because that is a special angle. So you'll get the gradient of line PQ is 1. Okay, and that's a nice, easy 2 marks to get us going. The next question says, find the equation of Mn in the form y equals mx plus c and give reasons. Now remember, you're dealing with a straight line, right? So what do you need in order to find the equation of a straight line? You need the gradient and you need the y-intercept. Do we have the gradient of Mn? Well, it's not given directly. However, they were sneaky. What they did in this question, and those of you who remember your geometry from grade 10 would have had no problem spotting this. They gave us a triangle where the midpoints of two sides of the triangle are joined. All right, do you see that? So in triangle PQR, the midpoints M and N were joined. So we have a theorem from grade 10 that says the line going from the midpoint of one side of a triangle to the opposite side of the triangle is parallel to the third side of the triangle and half the length of the third side. What is that called? That's called the midpoint theorem. So therefore, using the midpoint theorem, we can see and we can deduce that the gradient of line MN is going to be the same as the gradient of line QP. Okay, so that's where we start. The gradient of MN is equal to the gradient of PQ. You need to give reasons. Remember the question said, give reasons. And the reason there is you can state the whole midpoint theorem, or I'm just going to say midpoint theorem. Okay, so therefore the gradients are equal, so therefore the gradient of Mn is also going to be equal to 1. Now, in order to complete your equation of a straight line in standard form, yes, we've got the gradient, but we still need the value of c. There's two different ways you can do it. You can substitute the value for x and y given at the point n and then work out the value of c, or you can use the gradient point form of a straight line, which you've been using, but maybe you haven't recalled that that's what its name is. And in order to work out the equation of a straight line in this form, you'll need the gradient and you need a point. And we plug that in and then work out the equation. So y minus, well, y1, we see that the y value at point n is 1. The gradient of the line is 1. And the x value at that point n was 7. So I plug that into my equation. I get y is equal to, simplifying, 1x minus 7, take your minus 1 over to the right-hand side, it becomes plus 1. So I get y is equal to x minus 6. Okay, and that is the equation of this line, MN. Okay, that was 4 marks that all of you should have gotten quite easily. So if you understand how a tangent is related, the tangent of an angle is related to the gradient of a line, it really makes the first part of this very simple. And then also if you just remember those geometry theory that you learned from grade 8, from grade 9, that can come in very handy sometimes. Okay, guys, so we're going to carry on with this question after we take a quick break. We're back after this. Welcome back, everyone. In our analytical geometry revision today, we started off by looking at question 3 from the DBE November 2015 paper 2. Okay, the question that we just looked at had the first 2 parts where we had to find the gradient of a line and find the equation of a line, and now we're going to look at the remainder of that question 3. So if you do have a paper, you can go and refer to that. Otherwise, I just want to remind you what the question says. So I'm going to give you a couple more minutes to take down the next part of the question and understand how you will start looking for clues to help you with answering this question. So I'm going to give you 2 minutes to have a look at this question. Okay, everyone, so we're continuing with our discussion on this question 3, analytical geometry question, and it's the same diagram that you should already have from the first part of this question that we did earlier. So I'm not going to read the whole question again, but I want to go straight into 1.3 here, which says determine the length of MN. Now go back to your diagram, and from what we've just discussed earlier, we know that by the midpoint theorem, the line MN, since it's a line that goes from the midpoint of one side of the triangle to the midpoint of the other side of the triangle, is parallel to the third side of the triangle and a half its length. So therefore, MN is parallel to PQ, and MN is a half the length of PQ. Now, wouldn't it be nice if we had the length of PQ, because MN would just be half that? Well, they gave it to you, right? They said to you that PQ or QP is 7 root 2 units. So therefore, that means that this question, once we understand that we are using the midpoint theorem in this question, it becomes really simple. Okay, so the length of MN, well, we know that from the midpoint theorem, we're going to have MN will be a half the length of PQ. So it's a half of 7 square root 2, 7 over 2 times the square root of 2. And we can then just work that little value out on our calculator. Okay, so it's 7 square root 2 divided by 2, and that gives us 4,95. I'm just going to round that off to 2 decimal places, so it's 4,95 units. I don't think they said whether that was centimeters. No, they just said units. Okay, so we'll leave that as units. Okay, then the next part, and I think we have a little numbering problem here. So this is 1.4, and then the next one's 1.5. The next part says, find the coordinates of S such that PQRS in this order is a parallelogram. Now, if we go back to the diagram, let's note why it's important to get the order right. So we're going from P to Q to R and then to S. So that's a parallelogram, okay? So given that it's in that order is important, because if I then extend a line, all right, from the point Q to the point S, given that PQRS is a parallelogram, we will have that the midpoint of the lines PR and PQ would be at the point N, because remember what we know about the diagonals of a palm is that they bisect each other. So therefore this point N, which is 7 and 1, is going to be the midpoint of line PR and also the midpoint of line QS. So I'm going to call S the point XY. We don't know what the coordinates are. But working backwards from the midpoint theorem, because we have the midpoints of line QS, I can work out one of the outer coordinates in the following way. So we will have, in order to work out the midpoint, remember we would say x plus x1, so x plus negative 2 divided by 2 will give me the x coordinate of the midpoint, so x minus 2 over 2 will give me the x coordinate of the midpoint, and then y minus 3 divided by 2 will give me the y coordinate of the midpoint. So the midpoint being 7 and 1. So therefore working backwards, I will get that x is equal to, I multiply the 2 out of the left hand side by multiplying both sides by 2 over 1. So I get x minus 2 is equal to 14. Therefore x will be equal to 14. From taking the minus 2 over to the right hand side, we get 14 plus 2, which is 16. And then on the other side, to work out the y coordinates, once again, multiply both sides by 2 to get rid of 2 in the denominator. You get y minus 3 is equal to 2. Therefore, y will be equal to 5. So therefore, the coordinates of the point S, x is 16 and y is 5. Okay. All right. So that's a pretty standard question in an analytical geometry exam question. Let's look at the next one, the length of RS. Okay, so let's go to the diagram and look for RS. Now remember, they've also told you that this is a parallelogram. PQRS is a parallelogram. So therefore, we know that RS is going to be equal to PQ, because we know that the opposite sides of a parallelogram are equal. We know that PQ is 7 square root 2, therefore RS must also be 7 times the square root of 2. So the length of RS is 7 square root 2. You can work out that value on your calculator. I'm not going to do that, but you can do that. Okay, let's go straight into the next one. Now, this one is a little bit longer. You asked to find the coordinates of P. Now, when we locate P on the diagram, okay, have a look at where P is sitting. P is at that point on one of the vertices of your parallelogram. It has coordinates A, B. We don't know what the coordinates at R are. All we've got is we've got the coordinates of S and we've got the coordinates of Q. So now you've got to start thinking, well, how can you work out the value of these coordinates? We obviously cannot use the point R at this stage because it means it's going to be more work, because we're first going to have to find R and then work out the point P. So that's going to be a lot more work for just 6 marks. So we already start eliminating the point R from whatever we're going to do to find the point P. Let's look at what information has been given that we can use to help us work out the point P. Well, for one, we know that PQ has a length of 7 square root 2, and I also know that there's a distance formula I can use to help me work out that length PQ. We know that the gradient of line PQ is 1, and we also know that the point P lies on the line PQ, which we already have the equation of that line. Remember, we worked out the equation of that line. In fact, I'll just go back and show you. We worked out the equation of the line we worked out the equation of line MN, so it wasn't PQ. All right, so we've got the point. The line y is equal to x minus 6, and that was the equation of mn. Okay, so mn is not really going to help us, but pq's gradient can help us. Remember, we know that the gradient of pq was equal to 1. Okay, so let's go back here. And we realize that we need to now use simultaneous equations to help us work out the coordinates of point P. We've got 2 ways that we can relate information that we are given to the point P. The one thing we can do is we can use the distance formula from P to Q by saying PQ squared is going to be equal to 7 times the square root of 2 squared, because that is the length of PQ. And we can then plug in the values of A and B as a coordinate and work out what our values for A and B, or A in terms of B, would be. I just need the coordinates of Q. Q is minus 2, minus 3. Okay. So let's substitute that into our distance formula. So PQ squared is going to be A minus 2 squared. So it's A plus 2 squared. This comes straight from substituting into my distance formula, which you should all be familiar with now, which is given to you on your formula sheet. And then B minus 3 squared is equal to 7 squared, which is 49, times 2. Okay, by squaring the right-hand side. So I get A plus 2 squared plus B plus 3 squared is equal to 49 times 2, which is 98. Okay. All right, guys, I'm not going to simplify that further right now. I want to first get another linear equation that can help make this process a little bit quicker and a little bit easier. So let's not substitute or try and work out a value for a and b just yet. Okay, we're going to leave this as is, and we'll call this equation 1. Where do we get the other equation from? Well, we know that the gradient of PQ was 1. So therefore, gradient we know is y2 minus y1, and remember y1 is minus 3. So we use a bracket so that we don't make a mistake with our signs, over x2 minus x1, which is minus 2. And that's equal to a gradient of 1. So we end up with b plus 3 over a plus 2 is equal to 1. All right, and you can see that I got the positive 3 by saying minus 1 times minus 3, and I got the positive 2 by saying minus 1 times minus 2. I'm going to then times both sides by the a plus 2, so find an LCD, so I get b plus 3 is equal to a plus 2 by multiplying both sides by my denominator. Therefore, b is going to be equal to a minus 1. How did I get that? I took the plus 3 over to the right-hand side. It became a negative 3. Negative 3 plus 2 is minus 1. We'll call that equation 2. And now we're going to substitute. So we're doing a simultaneous equation. Substitute equation 2 into equation 1. And then work out the values for a and b. So we end up with the following. We get a plus 2 squared plus, now in place of b within the bracket, I'm going to replace b with a minus 1 from that equation, right? So in place of b in this bracket, I put in a minus 1, and then we've got plus 3 squared is equal to 98. So this looks good. I'm going to end up with a plus 2 squared plus a plus 2 squared is equal to 98. Now guys, at this point, you can actually expand those brackets and then add your like terms and do a trinomial and equation, solve for a. I'm not going to do that because I see that I've got both the same brackets, right? So I've got 1a plus 2 squared plus 1a plus 2 squared. So those are same terms. So this is going to become 2 of a plus 2 squared. So I'm going to do the solving for a here a little bit differently. So I end up with 2 times a plus 2 squared. Divide both sides by 2 and you get a plus 2 squared. 98 divided by 2 is 49. All right, I want to get rid of the square, so therefore I'm going to square root both sides. So I get a plus 2 is equal to the square root of 49, which is 7, or the negative square root of 49, which is negative 7. So therefore we get a is going to be equal to 7 minus 2, which is 5, or a is equal to minus 9. Now, this answer, a is equal to minus 9, is not applicable. And the reason we don't use a is equal to minus 9 right in the beginning, they said to us that a and b are greater than 0. We also saw that that point P falls into the first quadrant. So therefore, a is equal to 5 is the answer for the x coordinate at point P. What's the y coordinate? I'm simply going to take that, substitute back into this equation. B is equal to a minus 1. So I'll get b is equal to a, which was 5 minus 1. All right, and we get that b, or the y coordinate at point P, is 4. Okay, so that is quite a process, and the thing that makes it so long is doing the simultaneous equation. You guys know that whenever you work with simultaneous equations, it's going to be at least half a page of work. So you've got to give yourself enough time and pace yourself properly so that you have enough time to go over this question and make sure you haven't made any careless mistakes, because this can be easy marks as long as you don't make careless mistakes. Okay, let's take a quick break so you can get all of that into your head. And when we come back, we'll look at another question, our last question on analytical geometry. Welcome back, everyone. And now we're going to look at our last question for our analytical geometry today, our revision session. And this question comes from November 2015. Paper 2, it's question 4. We don't have much time to go through the entire question, so I want to get as much done as possible. I'm going to give you a few minutes just to get familiar with the question and take down the key information that you need from the diagram and possibly to draw the diagram. Okay, so I'm going to give you 2 minutes starting now. Right, everyone, so hopefully that was enough time for you to take down the diagram at least. Otherwise, you're going to get a little bit more time now. If not, as we go through it and we mark down information on the question, you'll get some time now to take down anything you might have missed. Okay, so let's read the question. We are told that in the diagram below, Q, which is the point 5, 2 is the center of the circle. So you've got the x point at the center is 5, the x value at the center of the circle is 5, and the y coordinate is 2. That we see that in that circle, the center of the circle, and then they say that the circle intersects the y-axis at the point P. Okay, so they've given you the y-intercept, one of the y-intercepts of the circle. That's the point 0.6. All right, so we can fill that one in, and it also intersects the circle, the y-axis at the point S. Let's go back. The tangent APB at P intersects the x-axis at the point B and makes an angle of alpha with the positive x-axis. So you've got your tangent APB, all right? You see that it makes an angle of alpha with the positive x-axis, or in the direction of the positive x-axis. And they tell you that R is a point on the circle. There we go, there's R there. and the angle PRS is theta, so that goes in there. Okay, everything that they gave us in the question has been given to you on the diagram. The first question says, determine the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. So that's pretty standard. That's find the equation of the circle. Your standard form of any circle that's not centered at the origin is given by that equation. That's our standard form, all right? What do we need to be able to complete the equation of the circle? We need the center, which we have, and we need the radius, which we can work out. All right, so the center, the points A and B are given by 5 and 2. We still need the radius of the circle. Now, if I join this point Q to that point P, okay, that length is going to be the length of the radius of the circle. We're going from the center of the circle to the circumference of the circle, so obviously that length would give us the radius. So to work out the radius of the circle, we need the length of PQ. Okay, so just using our distance formula here, so we've got P is the point 0.06, and Q is the 0.5 and 2. So therefore, by the distance formula, we get PQ squared, which will then give us our radius squared, and that's going to be 0 minus 5 squared, by just substituting into my distance formula, plus 6 minus 2 squared, 0 minus 5 squared, so it's going to be negative 5 squared, which is 25, plus 6 minus 2, which is 4. 4 squared is 16. 16 plus 25 will give you 41. Okay, so your radius squared is 41. Obviously, your radius would be the square root of that. Okay, we're not going to go and square root that. We need that in that form so that we can plug in x minus 5 squared. So I'm now putting this into standard form to find the equation of my circle. X minus 5 squared plus y minus 2 squared, where 5 and 2 are the coordinates of the center of the circle, are equal to r squared. Okay, so that's the first part of the question done. Okay, next part. Calculate the coordinates of point S. Let's have a look at where S sits. Now, as you can see, is the other y-intercept of the circle. Now, guys, how do you find the y-intercept of any function at all? What do? We let x equal 0. So this might be a section in analytical geometry, but it doesn't mean that we need to forget all of that other stuff that we know about functions and graphs and non-functions. In this case, it's a non-function, all right? But to find the y-intercept for any graph, we let x equal 0, okay? So therefore, since I have my equation of the circle, to find the y-intercept, I'm going to say let x equals 0, because at the y-intercept, your x-coordinate is always 0. So we get 0 minus 5 squared plus y minus 2 squared is equal to 41. So y minus 2 squared is equal to 41 minus 25, and I'm going through those steps quite quickly. All I'm doing there is squaring the minus 5 and then taking that over to the right-hand side. So what is 41 minus 25? We saw that that was 16. All right, so therefore, to now solve for y, I'm going to square root both sides. So I get y minus 2 is equal to plus or minus the square root of 16. Obviously, you can expand out and then factorize your trinomial again. That's a little bit longer. The square root of 16 is positive 4 or negative 4. So therefore, we're going to get y is equal to 4 plus 2, which is 6, or y is equal to minus 4 plus 2, which is minus 2. So if we're looking for coordinates, the one at point P, that y-intercept was given as 0 and 6, so therefore S must have the other coordinates, which is 0 and -2. Okay, which is the one we've just worked out. And it makes sense for the coordinates at point S to be negative because we are on the axis, you see, on the negative side of the x-axis. All right, guys, so let's quickly have a look at the last part. I want to get as much of this done as possible. We then say determine the equation of the tangent APB in the form y is equal to mx plus c. So to work out the equation of a straight line, what do you need? You need the gradient, you need the y-intercept. This line APB, we can see that it cuts the y-axis at the point 6. We've got the y-intercept. How do we then work out the gradient of this line? What do we do? So this one's a little bit tricky. Let's go through this quickly. We see that, and we need to remember, and this is why I said that geometry theorem from grade 11 is important, our circle geometry. The radius is perpendicular to the tangent at the point of contact. That's a theorem from geometry, radius perpendicular to tangent. We know that APB is a tangent, so therefore where the tangent meets the radius, the angle is 90. How does that help us with our current problem? Well, once we've got the gradient of PQ, then the gradient of this line AB is going to be the negative inverse. Why? Because we know that the product of the gradients of perpendicular lines is equal to -1. So all I need to do to work out the gradient of this line AB is work out the gradient of PQ, and then the negative inverse will give me the gradient of line APB. Okay, so let's do that quickly. All right, so this is now 2.3. The gradient, firstly, of the radius. Remember, we have to work out the gradient of this radius first to help us to work out the gradient of the other line. So the gradient of PQ, okay, is going to be equal to, so we know that the point P is 0, 6, and the point Q was 5 and 2. So the gradient will be y2 minus y1 over x2 minus x1. 2 minus 6 is -4 divided by 5. All right, once I've got the gradient of PQ, and guys, I'm going to quickly go through this because we are running out of time. The gradient of line APB is going to be the negative inverse of the gradient of line PQ, because we know the gradients of those two lines, the product of those gradients is -1. Okay, because these lines are, these two, radius is perpendicular to tangent. Okay, so therefore the equation now of this line will be y is equal to m x plus c, and what was the y-intercept of line APB? It was 6. So therefore the equation of our line PQ is 5 over 4x plus 6. All right. Okay, guys, so we're not going to have time to finish off this question. There are more parts to this question. If you're going through your past papers, you will see that there are a continuation to this question 4 in the 2015 paper 2. All right, you've got enough information, and I've given you enough tools already to take all of this that we found out and help you to finish off this question, okay? So while you get the time, you know that you need to be revising past papers. Get a hold of this past paper and finish off this question. There are more parts to this question, okay? All right, guys, so really our top tip for today was to remember to prioritize your exam revision. Don't study while you're talking to a friend online or anything like that. Make sure that your main priority when you are studying for exams is to set aside special time in a quiet place with no distractions, all right? And by now, as you know, you should be going over past papers. Okay, guys, that's it for me. Until the next time and until more revision, goodbye.